So the two questions that I promised you. Okay, so the first one shows us calcium. Sorry, I'm trying to make it clear, but I don't know that it actually is. So it's calcium solid, and so we with okay. So if we write it dissociate, this is a solid. It'll be H positive aqueous plus NO3 negative aqueous going to H2 gas plus Ca2 positive aqueous plus NO3 negative aqueous. Okay? So then if we look at the charges, the one that isn't changing is NO3, so it becomes our spectator. And so our two half reactions will be Ca solid going to Ca2 positive aqueous and H positive aqueous going to H2 gas. Okay, so the next step is to figure out what are we adding, how many electrons to which side. Sorry, I was lowering the television. So we have Ca solid, it's 0, it goes to 2 positive, so it must have lost electrons. So over here we have to add, and we have to add 2. Here we have an H positive going to a 0, so obviously it's gained electrons. On this side though you have 2 hydrogens, over here you only have 1. So before you add your electrons in, you have to put a 2 there, and then you add 2 electrons here. Okay, electrons are balanced. We can add our two half reactions together. So we have Ca solid plus 2 H positive aqueous going to Ca2 positive aqueous plus H2 gas. Alright, our last steps are to say, okay, is calcium gaining or losing electrons? It's losing electrons. Losing electrons is oxidation. Whereas hydrogen is gaining electrons, and gaining electrons is reduction. And then our very last step, so if calcium is being oxidized, it means it's the reducing agent. And if hydrogen is being reduced, it means it's the oxidizing agent. And we're done. All right. D. D is aluminum plus copper oxide. Okay, if we write it dissociated, that's aluminum solid plus Fe, 2 positive aqueous plus O, which is 2 negative aqueous. Remember the O dissociates, we talked about that today, it's not O3. Going to Fe solid plus aluminum, which is 3 positive aqueous, plus O, which is 2 negative aqueous. And again, the 3's and the 2's, they disappear. They'll come back when we balance them. If we look at what's changing, aluminum is going from 0 to 3 plus. So aluminum solid, Al3 positive aqueous is going to be one of our half reactions. And iron is going from 2 positive, Fe2 positive, to Fe solid. And if you check out the O2, it's just hanging out as O2. All right, where do I add my electrons? So for the aluminum, this side is 0. This goes to 3 positive. So to make the sides balance, I need to add 3 here. For iron, this side is 2 positive. This is 0. So to make it balance, I need to add 2 here. All right. I can't add them together yet. They're not balanced. Need to multiply this one by 2. Need to multiply this one by 3, and now I can add them. So I will have 2Al solid plus 3 Fe2 positive aqueous, sorry, lost my aqueous there, going to 2Al3 positive aqueous plus 3 Fe solid. Now all we have left is oxidizing and reducing. So the aluminum is losing electrons. They're over here on this side. So that means this is oxidation. The iron is gaining electrons. So that means this is reduction. And then down here, Al was oxidized, which means it must be the reducing agent. Iron was reduced, which means it must be the oxidizing agent. And that is number 3 and 4, C and D. I did ask you to look at number 5 as well. And there's a little trick in number 5. Because number 5 says ionic compounds can react in double replacement reactions. Predict the balanced chemical equation for the reaction of an aqueous solution of iron 3 chloride. So whoops, sorry, my paper is uneven. FeCl. Oh, I guess I didn't need the brackets. I could have just put the 3 there. Okay, so let me try that again so it'll actually be neat. FeCl3, because it says it's iron 3 chloride, and sodium hydroxide. So NaOH, they are both aqueous. And it says it's a double replacement reaction, which means the Fe is going to pick up the OH, and this time I do need, and the Na is going to pick up the Cl. Again, both aqueous. So if we write these as dissociated, it will be Fe3 positive, aqueous, plus Cl negative, aqueous, plus Na positive, aqueous, plus OH negative, aqueous, and on the other side, Fe3 positive, aqueous, OH negative, aqueous, Na positive, aqueous, and Cl negative aqueous. So if you look to see what's changed, if I can get a hold of my paper, you would notice absolutely nothing, which means this is a reaction, but it's not a redox reaction. So you can have reactions that aren't redox. Redox reactions are specifically when there is an exchange of electrons. But you've done tons of other reactions in chemistry that weren't redox. So the whole point of this example is to show you there can be reactions that are not redox. So just in case you thought Mr. Jewett, Miss Lyons, Miss McDonald have been keeping you in the dark about the like not mentioning redox. No, there's only certain reactions that are redox, okay? So, and there has to be an exchange of ions. So this reaction is legit. It's a double replacement reaction, but it's not a redox reaction, which means we can't do these steps. There's no exchange of electrons because these entities have not changed their charge. Okay? Hopefully you were working on oxidation states tonight, and I'll see you in the morning.